Hello, welcome to Zelin's class, and today we are going to do two parts. The first part is definite integration, which is then recapping of AS level. And for the second one, it's integration of the fraction 1 over ax plus b, and that is a new topic, which is in A2 level. And now let's recap the basic definite integrations now. So firstly, for the definite integration, we write the integration like that. So the only difference between the indefinite integration is there are two numbers here. And these two numbers are meaning a range. So we can use definite integration to solve for the area of a particular space. So such as this is the fx and we have a and b are usually the numbers here. So if we want to calculate this part of the area, we can apply the formula integration from a to b and fx dx. So we can apply this. The a and b are usually just mean a range from a to b. Okay, so that is the basic idea of integration. And so how do we calculate this? Well, we have a way. Now let's just try the simplest question, which is from 1 to 2 integrate x squared dx. Well, the first step, we do the same thing as indefinite integrations, which we have a third times x cubed. And for here, we do not need to write c because c can cancel out when we are doing definite integration. So now, we will write the thing like in brackets and we have the range from 1 to 2. Okay, now let's do the second step, which is substitute 2 first. So substitute x equals 2 first, and we will get a third times 2 to the power of 3. And that is the second step. And for the third step, let's subtract the substitution of 1. So we also substitute 1 inside, and we use the value when we use the value of this minus the value of that, so we will get this equation. And this is what the answer for this question. And why do we subtract it? Well, the idea is actually also related to the area. So such as that is our fx and that is our, so like for example 1 and 2. So firstly, when we substitute 2 inside, we are calculating this area. So the area in front, so the area that the number smaller than 2, which forming an area, and here is going to the negative infinite. And this is what happens when you substitute 2. However, what do you want is you want 1 to 2. So what else do we need to do? Well, we need to subtract this part of the area, right? Because it's overcalculated. So we need to subtract this part of the area. And what is this part of the area? It's when you substitute 1 inside. So that is why we need to subtract these two. Okay, so that is the recap of AS level. And today we are going to do something new, which is I talked before, which is integration of the fraction 1 over ax plus b. Well, we learned so we can see that this looks like a linear equation, but it's just like to the negative power of negative 1. So like if we try to apply the skill we learned in AS level, such as we change this fraction into ax plus b to the power of negative 1. And if we want to integrate it, so we need to add plus 1 here and times something into the front. However, here it's negative 1 and plus 1, which becomes 0. And so which means we can't times anything to the front because this part is equal to 1. So which means that we cannot apply this way. So which means this way is not correct. So what can we do? Well, we learned in the differentiation part that y equals ln x. so the y dash is equal to 1 over x. So that is what we learned in differentiation. And we also know that integration is the opposite as the differentiation. So that means if we have integration of 1 over x dx, it will become ln x plus c. So we are not going to use this way, and we are going to just apply using this rule. So which means that 1 over x integration is equal to ln x plus c. And for the y equals 1 over ax plus b, because we know that y equals ln ax plus b, then y dash is equal to a times ax plus 1 over ax plus b. So here we need to divide it and a at the front, so we have 1 over a times ln ax plus b plus c. And now let's try to do a simple question. So for here we have 2x down the denominator, so which means we can't apply the first formula and we have to apply this formula. So because now 2 is equal to a, so we have 1/2 at the front and nothing else changes, but add a ln here and plus c, and we're done. So it's not really difficult if you understand the differentiation quite well. Okay, let's try a harder question, which is related to definite integration. So it's from -1 to 3, and then this function dx. Well, there's also a rule that we can split, if there's a plus sign here, then we can split the equation into 2. So we can write it like 2x minus 1 dx, and then plus another part, x plus 3 dx. So we can write it like that. Well, I think for me it's easier to do in one step. So let's just integrate this. So 2x becomes x squared, and minus 1 becomes negative x. And for this one, we will apply this rule again. So we have a as 2. So we have 4 times half, then times ln 2x plus 3. And from -1 to 3, and then we just sub the values. So the values are 9 minus 3 plus 2 times ln 9, then minus bracket 1 plus 1 plus 2 times ln 1. And that is equal to 6 plus 2 ln 9 minus 2 ln 1. And we also know that ln 1 is equal to 0, because e to the power of 0 equals 1. So we know that this is out. So we have 4 plus 2 ln 9. And that is our answer. Okay, so that is the end of this session. And if you want more questions about this, you can go to the channel by Daniel Dallas, and he will provide more examples. Okay, thank you for watching this video, and don't forget to subscribe. And thank you. I'll see you tomorrow.